Welcome to Module 8 of Political Statistics. In the last module, we put together everything we've learned so far in the class to use in a preliminary case study on student outcomes in higher education. We disaggregated data, observed stratified patterns of success, and briefly skimmed the literature for theories that could help us interpret our findings and build on them. Though we didn't make any groundbreaking discoveries, we got a better sense of the role statistics can play early on in the research process. This week, we'll shift our perspective and approach political statistics from the point of view of a practitioner. We'll step into the shoes of a campaign manager, see what we can learn from a previous race, and craft a strategy for winning. Let's get started. As we dive into this last module, there is no better time to reflect on the themes of this class. Having developed this course, what I hope you take away might not be what you actually take away, but if nothing else, I hope you keep these basic tenets in mind as you move beyond college and into your careers. First, that data and analyses never speak for themselves. That is, finding a pattern isn't the same as predicting the future. In fact, especially in political contexts, we're often looking for trends that we don't want to continue. We don't want voter disenfranchisement or stratified patterns of student success. But we can find patterns that predict, at least in the aggregate, the occurrence of these phenomena. Analysis requires theory, and not thinking about theory doesn't mean you don't have one in mind. It's just that you've left those assumptions unsaid. Second, you're never too clever to just count things. We've kept things fairly simple in this class. Bar charts, scatter plots, means and variances. These tools aren't lighting the world on fire, but to be frank, we don't need them to. As social scientists, the strength of your analyses doesn't come from using the fanciest and most complicated tools. It comes from the incisiveness of your theoretical contribution. That's just as true in today's example as it was for the last modules. So let's set the stage and dive in to see how those two themes come to the fore in our applied example. Congratulations, student. You have just been named the campaign manager for a candidate hoping to become the auditor of a suburban Midwest county. You've been tasked with helping this candidate win election. To that end, you've been provided with data on the results of the previous election, the demographics of each precinct within the county, and best of all, the geographic boundaries of those precincts. Given that campaigns work with limited resources, which include time, money, and labor, you know that you won't be able to simply blanket the county in canvassers, mailers, or phone banks. Rather, you'll have to strategically choose which precincts you want to focus on and which voters are likely to actually show up and vote for you. Ultimately, you'll also need to make the case that the strategy you settle on is a winning one to your candidate. So, some maps, simple charts, and acknowledgments of the limitations of our analysis will ultimately be very useful. That way, you'll not only have a clear strategy for everyone to align around, but if you notice that things aren't going to plan halfway through the campaign, you can pinpoint where things are going wrong and adjust. Let's dive in and take a look at our data. To aid in our task, we've been provided with two datasets. The first is the dataset with the geographic boundaries of each precinct and demographic data for each of those precincts. These variables include race/ethnicity, age, and home ownership status. That is, do people rent or own their homes? Second, we have a dataset that contains vote totals for each candidate, how those votes were cast, the candidate for whom they were cast, the precinct in which they were cast, and variables that capture the township and precinct numbers separately for convenience. We also know, as some background knowledge, that Bill White ran as a candidate for the Democratic Party and Bob Grogan ran as a candidate for the Republican Party last time. So let's start simple and see how close the race was overall last time. That race was really freaking close last time. A total of 75 votes separated these candidates out of a total of 466,167 cast. This is why your poli-sci professors keep telling you to care about local elections. But we can think about those eggheads later. We have a campaign to win. So our candidate of an unspecified party is probably going to want a strategy that builds on last time's results. If I'm Bill White and I'm running for another term, those 75 votes absolutely do not look like a great margin, and I don't like squeakers. If I'm Bob Grogan, I'm looking for a second shot at the position, and I don't want my heart broken by the same tiny margin. Well, if we want to build on last time, we should probably start by digging around and see what we can learn about this specific county. A good place to start might be to see how many different townships there are. Since each precinct is represented multiple times in our results data set, since there's a row for each voting method and candidate as well, let's use our map data set instead and see how many precincts there are in each township. That way, we get a list of all the townships as well as a rough estimate of their size. Precincts in general have about the same number of voters. All right, so it's a manageable number of townships, 9 in total, with the largest being Downers Grove and the smallest being Winfield. And in fact, that gives me an idea. While the total vote was awfully close between our candidates the last time around at the county level, that doesn't mean that it was necessarily all that close at the township level. Maybe each candidate totally dominated 4 townships each and split the last one. Why don't we find out by adding up all of the votes at the township candidate level? And since, as noted in previous modules, I have the attention span of a goldfish and hate looking at tables, let's visualize that summary as a dodged bar chart. So it would seem that each candidate had at least one very strong township that gave them many more votes than it did their counterpart. Bob Grogan ran up his margin in Downers Grove, while Bill White ran up his margin in Naperville. Besides those two, no other township really stands out to my eye, and it seems that they traded them roughly evenly. So at this point, maybe let's write down 2 things that we've learned that our candidate would be interested in knowing, or that would, at the very least, contextualize the strategy we ultimately end up on. First, that the race was really close last time, and second, that the race within townships wasn't as close as it was at the county level, and that unless we have reason to believe that things have changed significantly since then, which they might have, we might again build our margin in one particular township. Of course, our data goes one level further to the precinct, and we could do dodged bar charts all the way down to that level too, but since there are almost 930 precincts in our map dataset, I'm going to figure that the resulting visualization won't be very informative. Moreover, I'm starting to think that raw vote counts aren't telling me the whole story. We know, for example, how many registered voters each precinct has, so it might be more useful to look at these numbers as a percentage of total turnout within that precinct. Then we could create box plots within each township showing the distribution of voter turnout for each candidate. That way, we can identify whether our candidate's distribution of turnout was particularly low in a given township and whether that corresponded with high turnout for the other candidate. Well, this graph might have been a little too clever for our own good. There are some takeaways. For instance, that the range of turnout within a township is pretty large, spanning upwards of 20% for a given township. But beyond that, this chart is a little too complex to be useful. Let's simplify and make a scatter plot instead that shows us what each precinct's voter turnout was for each candidate. Well, that's kind of no surprise. As one candidate turns out more people to vote within a precinct, fewer people turn out for the other candidate. Precincts, after all, probably lean one way or another partisanship-wise, but it's clearly not a one-to-one. That is, everyone in a precinct isn't voting, so candidates aren't fighting exclusively over some handful of swing voters. Case in point, there are no precincts anywhere near the 50-50 intersection or the 60-40 intersection of the chart. Precincts at those parts of the chart would have 100% turnout. None do, or even get close. So let's write that down too, that focusing on turnout and getting more of our people to the polls is probably a viable strategy. And in fact, why don't we take a look to see which townships had better or worse turnout overall, and then by candidate? That's interesting. Overall, some townships had quite high turnout. If I'm working for Bill White, there might be an opportunity to pick off some of Bob Grogan's voters in Downers Grove and Milton, but those are pretty high turnout townships, so the opportunity for mobilizing new voters seems relatively small. By contrast, if I'm working for Bob Grogan, there's probably some opportunity to reduce the margin I lost by in Naperville, since that's one of the lower overall turnout townships, and my candidate lost by quite a bit there last time. So let's write that down. Focus on one or two townships to mobilize new voters. Which township, of course, depends on the candidate I'm working for. And 2, focus on one or two townships to erode my opponent's lead from last time. Again, which townships depends on the candidate that I'm working for. So far, we've only focused on one of our 2 data sets, and while we could continue down this path some more, I'm starting to get bored, and I want to make some maps. Maps are cool. And anyway, we have all this demographic data that we haven't even started digging into yet. Let's see how the demographics shook out in the last election. But first, let's make a simple map. I want to see what my county looks like. To do that, we'll use a library called Leaflet that produces interactive maps. Unlike ggplot, we'll have to do a little bit of extra work to create the color palette and pop-up labels, but the end result should be well worth it. Let's plot our county and color each precinct by the township it's in. Recall from our previous bar chart that Downers Grove, Milton, Lisle, and York townships were the highest turnout townships in the county. Interestingly, these townships all neighbor each other in the southeastern part of the county. That's useful to know. Remember, time is a limited resource, and your canvassers are far more likely to drive to a nearby precinct to canvass than they are to drive to a precinct that's way the heck out of the way. So the geography of our strategy might start to come into view here. Let's write that down. Try to focus on condensed townships. Now that I have a good sense of how my county is laid out, I may want to know what its demographics look like. Let's see what percentage of each precinct's population identifies as Hispanic or Latinx. And since continuous variables can often look muddled on a visualization if they're mapped directly onto a color, let's bin our variables so that similar values get the same color. It seems that Addison and Bloomingdale townships have numerous precincts with large Hispanic or Latinx identifying populations, while the 4 listed earlier, Downers, Milton, Lisle, and York, do not. Which brings up an interesting question. Is this a variable that was correlated with voter turnout in the last election? Let's merge this data back onto our election results and make another scatter plot. This time with the percentage of a precinct that identifies as Hispanic or Latinx on the x-axis, and the turnout for a given candidate on the y-axis. We'll also facet our plot by candidate and add a line of best fit using OLS. Well, now that's very interesting. 2 things immediately stand out. First, that Bob Grogan's intercept is higher than Bill White's, meaning that for a precinct that had 0% Hispanic or Latinx identifying people, Bob did better, while Bill White's slope is positive, meaning that the more Hispanic or Latinx identifying people that lived in a precinct, the better Bill did, on average. But before we write that down, let's take a moment to reflect on what it is we've actually learned and what we haven't learned. This chart doesn't tell us that Hispanic or Latinx voters are destined to vote or not vote for a given party's candidate, nor does it tell us that individual Hispanic or Latinx voters voted this way in the aggregate. Remember, this isn't voter-level data. It's at the precinct level, so our interpretation should stay at the precinct level. Moreover, there's a lot of variance here. Demographics clearly aren't destiny, which brings us back to the point I made at the beginning of this module, that interpretation should always be informed by theory. General political science theories about voting demographics are useful in this case, but it may be more useful for us to build a theory particular to this county. That is, how does this county behave? What issues matter here? What role do demographics play in mediating policy preferences at this point in time? In a sense, as practitioners, we're less interested in building broadly applicable theories about the average voter and more interested in building theories that will help us accomplish our goals. But we are still interested in building theories. And the important takeaway here is that those theories will inform how we interpret this data. If you're working on Bob Grogan's campaign, for instance, do you read this chart as evidence that Hispanic and Latinx voters simply aren't going to vote for you this time around? Or do you read it as evidence that there's a lot of room to improve with the Hispanic and Latinx community? If you're Bill White, do you read this chart as evidence that precincts with large Hispanic and Latinx communities are, quote, safe? Or that they deserve your time because they've turned out for you in the past? The data isn't speaking for itself. It never does. You interpret the data, and you'll likely have noticed that these interpretations aren't free of normative content. That is, our decisions to include or exclude certain precincts from our campaign efforts reflects on our assumptions about who belongs. Do campaigns avoid large Hispanic or Latinx communities because they don't reliably turn out to vote? Or do Hispanic and Latinx communities not turn out to vote because campaigns avoid them? We know from readings earlier in this semester that these aren't immutable relationships. Communities of color and other marginalized groups can be mobilized, and they often are. What we're looking at when we do political statistics is a snapshot of how the world was, not a decree telling us how it will be. So, how you decide to present that final finding to your candidate and how you orient your hypothetical campaign comes down to factors beyond the statistical tools we've become familiar with in the last several weeks. It comes down to theory, interpretation, and the normative values you bring to the practice of politics. I think that's important to keep in mind. As popular discourse about politics focuses ever more on the statistical analysis of perception, voter turnout, and prediction, we ought not to forget that politics is first and foremost done rather than analyzed. While the analyses of those actions can help us explain a lot and, in some circumstances, predict with a reasonable degree of accuracy, I'd argue that we've missed the point if that's all we care about. Politics is what we do, and statistics is a tool to help us do it. I hope over the last several modules that's become clear, and I hope you carry that lesson with you going forward. It's been a pleasure teaching this class, and I wish you the best of luck going forward.